We are gonna be live. Welcome back, folks, to BricsCAD Unplugged, Season 2, Episode 12. The closing of another season, you guys. With that, today's topic is Blade, creating dialog boxes, or DCLs. And with that, I'm Matt Olding. And Vince, can you introduce yourself?
Yeah, I'm Vince Amon with the sales team. And like I always say, a little splash of technical on the side.
Okay. And from down south in Australia, down under, Steve.
Hello. I am Steve Johnson.
Okay.
You may know me from such places as the blog Nauseum, and I do a few blog posts for the BricsCAD blog from time to time, written for Catalyst, done a few things.
And if you're a fencer, you know of Steve. He's one of the top fencers in Australia. Okay, with that, you guys, basically, before I get going, comments. Add your comments to Facebook, and somebody out there can win one of these BricsCAD coffee mugs.
And we're starting a new season soon, and so we want suggestions on what you guys want to see, right?
Yes,
so
yeah, please.
So what do you want to see in the next season as we start putting together more and more shows?
You got it, yeah. And then now, this is our third episode, you guys, on Blade, which is BricsCAD LISP Advanced Development Environment. It's always a mouthful to say. Yeah, that's why I have my little cheat sign here. But with that, the first episode we did with Steve, and it was basically an introduction to Blade. And then last week we did debugging, okay, with your list routines and everything. But today we're going to do creating dialog boxes, or DCL. And we're going to start off with the history of DCLs and then get into the code structure. And then the last thing we're going to finish up with is, of course, debugging your dialog boxes and then some of the differences on that. But before we get going, you guys, we forgot last week one very cool tool that's inside of Blade for this new release. And it basically helps out a lot in finding bug problems before you actually do a debugging session. And so, Steve, you're sharing your screen now. Can you go over this new feature? One, tell us what it is.
Sure. So it's hiding under this button here, which is the check syntax and variables button. And what we have here is an example that's very similar to the one I finished last week with, but I've put a few more problems into the code so you can see this working better. So in this function here, this broken code function, I've got a few problems, but instead of debugging it as such, I'm just going to check it with this magic little feature here. And you can see that it is giving us information about this function here, this C:example3, or this set variables one here, or this broken code one here. Now you can see the broken code one is red. That indicates it's got errors, not just warnings or hints, it's got errors. So if I click on that one and we have a look down here, we can see that in red we've got errors. And this is the one that Heidi identified last week, that BricsCAD doesn't have a bucket system variable. So it's telling us that system variable does not exist. And another one that I've put in here is this alert function. See, when I click on it, it goes to the piece in the code, so it shows you exactly where the problem is. So it's saying too many arguments for function call. So the alert function requires one string, and I've given it 2 strings. So it's just telling me all this stuff. And another issue I have here is I have used a variable here called int. Now, int is actually a reserved word in AutoLisp, BricsCAD Lisp, and it's saying it's predefined symbol and should not be overwritten. So I've done a bad thing there. It's telling me not to do that. And also it's showing me that I have an unused variable. So I've defined the function here. I've defined a local variable. I'm not using it anywhere. So it's just telling me about that.
It's very cool.
Yeah.
And if we actually look up here, we can see the variables that are being used, and we can actually say, okay, well, I'm not using that. I'm going to get rid of it. But I am using side1 and int, which I would rename naturally. And so all I have to do there is hit apply, and it fixes it up for me in the code. No typing, nothing. Just pick a few boxes and away you go, and it's fixed the problems for me.
Very
so
nice.
That's a very brief description of that feature, but that's a really powerful feature and can save you heaps of time and save you having to do any debugging at all. Really, really nice.
Yeah.
Anyway, on to DCL.
Yeah, and Steve, the history of DCL. I know yesterday you showed us a really cool DWG file about the history of DCL, and I'm a history buff, and so I love hearing stuff about this and how it was created and where it is today.
Okay, so that over there. Okay, so yeah, once upon a time, AutoCAD was a DOS-only program, and that was the case up to release 10 of DOS, and then a few other platforms got introduced. So we had Unix was introduced in '89, and the first Mac version, and then in 1990 we had the first OS2 version. So OS2 is going to be the next big thing, and that was going to take over. That was before Microsoft and IBM fell out. But in the second release for OS2, which was going to be AutoCAD Release 11, the Autodesk developers were really smart, and they did a really smart thing, and they produced a system of platform-independent dialog boxes that could be user-defined. And this is what we have today as a result of the guys who did this. And so originally it was just in OS2 for Release 11, which very few people actually used. But then in Release 12, it started to become very, very valuable feature. And so the DOS and Windows releases of Release 12 came out. And the idea of this was that you could write code that defined a dialog box, and then each individual platform, whether it's Windows or OS2 or Unix or Mac, would display it as it should be displayed on that platform. So they look like Mac dialog boxes, or they look like Unix dialog boxes, and so on, with only one piece of code. You don't have to rewrite anything. So that was really smart. And the shaded area here shows you where DCL has been supported by AutoCAD over the years. I'll just move that so you can see what's going on there. So here's the Mac line and the Unix line and the Windows line, DOS line, OS2 line. Now, over time, we got to Release 13 and things reduced down a bit. And when we got to Release 14, it became Windows-only product. So all this platform-independent stuff didn't really matter anymore. So it was just Windows, 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 until we get to year 2012 and Release 2013, where the Mac version, the second iteration of the Mac version of AutoCAD appeared. But unfortunately, that doesn't support DCL. So that's not within our shaded area here. So any code that was written for dialog boxes just won't work on that platform. So that's the AutoCAD story. If we just zoom out a bit, we can see the BricsCAD story.
Wow.
So going back to at least version 8, and possibly before, it's lost in the mist of time, but at least version 8 we've had DCL support, and that's been in the Windows version thereafter, right up to present day, version 19 up here somewhere. And when the Linux version was introduced in 2010, I believe, the version 10, that immediately supported DCL, and the Mac version also immediately supported DCL as soon as that was introduced. So you can just zooming out here, we can see that on the Autodesk side it narrowed down, and on the BricsCAD side it's expanded out.
So Steve, it's been like a 28 years span, is that what I'm counting?
Yeah, 28 years span. So I can do my development here in BricsCAD version 19 Windows, and it will work. The code, the LISP and the DCL code will all work anywhere inside this shaded area or this shaded area. Okay, so I can write stuff there and it will work here.
Nice.
It will work fine. And even back in the day when AutoCAD had a Unix version, I took a piece of code that I'd written for the LISP 12 DOS. I took it to a site that was using Sun Spark stations. For those people who can remember that was also the big thing.
I remember those.
Yeah.
And so I took this bit of LISP, this bit of DCL, copied it over. I'd never seen a Unix AutoCAD station before. I just loaded it on and it ran, and it looked like a Unix dialog box. I didn't have to do anything, and that's one of the real great advantages of it is zero maintenance. So I've got stuff that I've written in the mid-90s that still works fine now. No work at all.
Cool.
All right, so that's where we are with the history of DCL.
Yeah. What about some of the code structure now?
Okay, so let's have a look at what the code looks like. Let's go into Blade. Now I've got a very simple example here. So here's a bit of DCL code. As you can see, it doesn't look like Lisp. It isn't Lisp, and in fact, it's independent of the code that's calling it. So this DCL could be called from Lisp, or it could be called from ADS, which was the old C-based language, or BDS in BricsCAD, or ARX or BRX. It doesn't matter. It's the same DCL code. So it's independent of the language that's calling it, and it looks a bit like C++. Shares some features. It uses these braces here to indicate grouping. It uses semicolon to indicate end of a line. It has some object-oriented features, so you can define things, and then the attributes of those are inherited. So all that sort of stuff that's a bit C++ like. And the idea of the code is that we define widgets, and a widget could be a dialog, or it could be a row or a column, or it could be a text box, or there's a whole bunch of different things, radio buttons and all that sort of stuff. So you can combine these things together, and you tend to group them into rows and columns so that they all line up nicely. Now, to see what the code will actually produce when you run it, we've got a magic button here, a Dcl Preview Button. So if I push that, we can see what this code here will produce. That's it? So that's it.
7 lines, and that's the dialog box we get, the hello.
That's the dialog box, yeah.
I can do that.
Yeah. Even you could do that, Matt. Yeah.
I really like the preview button. That is very cool, because I've always had to use some other application to show my dialogues without running them. So that's a really cool thing.
Yeah.
Yeah. To be fair to Visual Lisp, there is a preview button in there, although it may not be immediately obvious. Anyway, that's nice. We can preview that. More complicated examples of DCL. We've got a much bigger file here. Instead of 7 lines, we've got 824 lines. A lot of it's comments, but still. So that can have multiple dialogues in it. And if I click on the Functions tab over on this side, you can see that we've got the different. Instead of the functions being listed here, we've got the different dialogues being listed. And if I double click on it, it takes me to that bit in here. So the Blade environment isn't just an editor that understands DCL files. It's deeper than that. The functionality goes deeper. It's not just simply another editor. And this is bidirectional, by the way. So if I click somewhere in here, then it shows me here where I am in the structure. So I have 5 dialogues defined in this particular example, and the preview allows me to show one of them. I'm looking at the list layers one here because that's where I am, and I'll OK that. And then we get this thing here where we have more than one dialogue to choose from, and I can choose which dialogue I'm going to look at. So I'm going to just look at the main one here. So this is an example of a much more complex dialog box that's been done in DCL, and it can take a bit of trial and error with rows and columns and all sorts of stuff in order to get things to all line up nicely with each other. But this DCL will produce code that looks nice in any of those platforms, and it will look as it should. So I've used some of the object-oriented features of the language with inheritance and so on in such a way that I can change a number here, and it will quite nicely change the appearance of the dialog box. Let's just do that quickly. So it warns me I need to save it. Yep, I'm going to save it, and there you can see I've widened that up. So I decided, okay, I'm going to need more space in the edit boxes. I'm going to change that from 15 to 25, and there, bang, it's done it. And everything all kind of lines up nicely. So it is possible to write code like this. It's not drag and drop. It's not instinctive and that, but it will produce code that is zero maintenance, and that's, to me, is more important.
Yeah.
Yeah, it can be a challenge to get the rows and columns all lined up and looking good, but once it's done, it's pretty stable that way.
Yeah. Yeah. All right. So that's the basic structure of the DCL code itself. So remember, it's platform independent. You use the same DCL code for BricsCAD in Linux or AutoCAD for release 12 for DOS. It's all exactly the same.
Yeah. What about Lisp code?
Okay, so the Lisp code, if we go back to our simple example again. So the least that you can do in order to make this DCL work is to have 4 things happen. And this is the minimal example here. So the 4 things are, the first thing we need to do is to load the DCL file. And there's a load dialog function for that. And that specifies the name of the DCL file there. We then initialize the dialog. There's a new dialog function that does that. Still at this stage, nothing's appeared on the screen yet. Then we use the start dialog function, and at that stage it appears on the screen. And this is where the action happens. So at this point, the program control, instead of after finishing start dialog immediately going down to the next bit of code, at this point it pauses and gives control to the user. And so once the start dialog thing is run, the user effectively works out what the program control is going to be. Because when they click on a certain button, in a more complex example, it goes to the bit of code that controls that button and so on. And only when the user picks OK or cancel does it get out of the start dialog bit and then continue on to the rest of the code. And once it's done that, then it does the 4th thing here, which is to unload the dialog, and that just releases it from memory. So that's the 4 basic things, and let's just run that. So I'm just going to load that and run the function, and there it is. So that's run. So at this point, it's got to the start dialog bit, and it's paused at this point. And as soon as I pick OK, then it carries on to the rest of the code. So whatever you have underneath here. In this case, I'm just unloading it and doing nothing else. But you could do other stuff in there. But the important thing to realize is that at this point, the code will be paused. Now, a more complex example, I have, I'll show you the dialog box first. This is a mini calculator that only does division. So you take one number and divide it by another, and it gives you the result. Now, you could expand this, of course, and make a real calculator out of it. Nothing to stop you doing that. But that's the purpose of this bit of code here. So you can see the DCL here is slightly more complex. We've got 20 lines of code there to do that. And we have different edit boxes. So those are the little boxes where you type the code in, and there's a text item here that shows you what the result is. Pretty much the rest of it's all as it was for the hello stuff. So the code to do that, all that division stuff, is here. So we got 60 lines of code. It's not too complicated, and there's a lot of comments in here. So we could probably get that down to like 25 lines of code if I was a bit more economical. So in this example, we have 7 things that are going to be done, not 4, because it's doing more complex stuff. So the first thing I'm going to do within my main function is I'm going to define any functions that I'm going to use later. In particular, what we call callback functions. So you'll see that I've named them call divisor and call dividend here. Those are going to be called later when the code is actually running. And also I've got a function here for setting up the tiles, so it places any default values in and that sort of thing. I've also got the thing that actually does the division there. So that's the first thing, is just define any functions we're going to use later. The second thing is to load the Dcl file, as we did before with our load dialog function. We're then going to initialize the dialog with new dialog. And then, this is a step we didn't have before, we're going to set up callbacks. So with this action tile function, we're going to associate the edit box, which is called divisor in the DCL code, with this function here called divisor. Now, it don't have to be named like this. This is just what I've called them. But what this means is that when the code's actually running, when the edit box does something, like somebody types something in and presses enter, then it will start running this bit of code here. It runs the call divisors. This is what links the stuff we defined earlier with the actions that the user's undertaking. So the fourth thing is to set up the action tile calls, or the callbacks as they're known. Then we set up the dialog contents itself. Now, remember at this point, the dialog box isn't actually yet displayed on the screen, but we can set the contents of the dialog up first and then display it. So that's what we're doing here. We're setting up a few variables. I've got a function here called setup tiles. If I look up here, what it's doing, it's using this set tile function to place values within the edit boxes. So setting up the dialog contents is the 5th step. Now the 6th step is display the dialog box. So at this point, the dialog box appears, and then after this, program control pauses. And the user picking the buttons is what makes stuff happen. And the user picking the divisor edit box and typing something in and pressing enter will make it call divisor function up here. So it's not the traditional linear sequence that you get in a traditional LISP program. It's based on the objects within the DCL code.
Okay, it's a little different.
It's a little different. So when the user's done that and finishes with a cancel or OK, it then continues the program execution here and does the 7th thing, which is the unload dialog. So this is the sequence that we have here. Now I'll show you later that these things that you do here is actually quite nicely defined in the BricsCAD documentation on the website. So I'll just show you that a bit later. But you don't have to remember that or play this video back again and again. All right, so let's run that and see what happens.
Yeah.
So I'm going to load the code.
I'm doing a drum roll.
Call the function, run this command /function, and there it is. So now we have our code running. These are my default values. I've got 1,000 divided by 10 is 100. So I can put any number in right here I like. Ooh. Where's it gone? Oh, I broke it.
Oh.
Oh, I broke it. Okay. I must have hit the cancel button or something. Let's try it again. Let's run it. Okay. Yeah, I picked the OK button, which finished. Yeah, my fault. Operator error. It's not code. It's the operator at fault here. So there we go. So we can put any numbers in here we like, and of course it's going to work perfectly, isn't it?
Yeah.
What if you do break it? What if you put in a 0? Make it divide by 0.
Okay. Well, if you okay. So here's a man that's done some software testing in his time. So
this is what the users always come back with. It doesn't work.
Yeah, that's right. It doesn't work. It doesn't work. Okay. So this number, any number, divided by 0, and it goes away. So if we have a look at what's happened in BricsCAD, what the user would actually see, and we flip to the text screen, we can see, as we mentioned last week, we get this this call stack appear. So this function is called this function, calls this function. Here's the bit of code that failed, dividing the dividend by the divisor, and here's the error that occurred, divide by 0. And because it's a dialog box, we also get another couple of errors appear thereafter. So that's traditional using the code. It's not debugging. We can actually debug the DCL. So let's do that.
Yeah.
So if you remember from last week, to set a debug session going, this play button here is the key to everything. So I'm going to start the debug session. I'm going to load the code within the debug session, and then I can run the code and run this command function. Now it stopped execution at this point. If you remember last week, this feature called auto break is turned on. It just stops execution at this point here. And you can see down here there's some the useful stuff appears in the local variables here, but we're not going to use that at this stage. I'm just going to let it continue. So now the code is running, and we have our dialog box, and now we're going to mess it up by putting a 0 in. And as soon as I click elsewhere, or as soon as I hit enter, then the error will be triggered. There we go. So as before, within the debug session, it's giving us useful information. It's saying there's a divide by 0 at the / function or the divide function. We pick OK, and it takes us to the code. It shows us exactly where the code is going to fail. Now, it hasn't actually failed at this point. If you remember last week, the debugger pauses execution before running the bit of code that causes the error. So it's a mind reader. It's telepathic. It knows what's going to happen here.
I like that.
Well, this is great because you don't have to use Task Manager to kill the dialog box by killing the application. Yeah.
Okay, yeah. Here's a man that's done debugging of DCL code in another application.
Yeah.
That when things go wrong, we don't get this nice behavior here where
right.
We can see what's going on. It will lock up the application, which will remain unnamed, and you have to use Task Manager to end the task and then restart it.
So speaking of that, though, Steve,
depending on circumstances, could be a couple of minutes before you get to start writing code again. All right. So anyway,
but speaking of that, can you talk about other differences between what we can do here? Are there other things that you could mention between other CAD and BricsCAD when it comes to DCL?
Okay. All right. Well, yeah, we're going to have to name it. So. The AutoCAD and BricsCAD engines that are used to display the dialogues are different. So occasionally you see some superficial differences in the way the dialog boxes appear. So this is all part and parcel of the platform independent nature of DCL. So the definition in the DCL gives instructions on what's needed in the dialog box, and then each platform follows those instructions in its own way.
Right.
So that appears slightly different from platform to platform and from AutoCAD to BricsCAD. So things may appear slightly differently. It'll all be there. It'll all work. It will just look slightly different. And depending on how kludgy you've been on setting up your DCL, things might not line up. Occasionally you do see things that display differently in a slightly significant way because it uses different fonts. And if you specify particularly a fixed width font within a list box. And I've got an example here of a dialog box that's in AutoCAD. And this is set up so it shows you one thing over here, another thing over here, and then the third thing over here. And you can see the font there it looks like one thing. And if we look at the BricsCAD equivalent of that, the font is a bit different. You also see it nicely separates them into lines here, which I quite like. But you have to scroll over in order to see this column here. So that kind of problem can occur. 98% of the cases it's not going to occur, but occasionally it can occur. But there is a solution for it. So I'm going to now show you the BricsCAD developer reference. And in here, it talks about BricsCAD specific attributes. So within the DCL code, you can define a BCAD width. And what that does is, in BricsCAD, it uses that for the width of the dialog box or the width of the edit box or the widget or whatever it is that you're talking about. But AutoCAD will just ignore that. So it's as if it didn't exist. So any attributes you put into your DCL code that AutoCAD doesn't know about just get ignored. And that includes all of these. So you can modify your code very slightly, put a BCAD width equals and a different number in there, and a width equals a different number, and then it will be handled differently in AutoCAD and BricsCAD in order to allow for the different size fonts. So that's the only time you're going to need to mess with the DCL in order to retain its platform independence, if you like. Most of the time, there's no difference. You don't need to do anything. It just works. It's platform independence. The guys that did the Autodesk developers that did the OS2 stuff back in the early 90s need a pat on the back for producing this platform independent stuff. It's great. So guys, if you're out there, well done. Thank you very much.
Yeah.
We're still using your work.
But now, at least 20 years later, we're finally getting some new commands for the DCL language to do some more stuff.
28 years, yeah.
28 years, yeah.
Hey, we're running out of time, you guys, but Steve, I have a general question. If you know AutoCAD and Vid in that environment for, doing Lisp and dialog boxes and so forth, how long do you think it would take somebody to get up to speed with Blade, coming from that environment?
Well, the people that are familiar with that are going to be fairly cluey. So you're not going to have to teach them programming or anything like that. Just teaching them the new stuff in Blade, although there's a lot in there, I think you could cover it in half a day.
Oh, good. Okay.
I think, yeah, I mean, a day maximum, but I think half a day you could probably do provide very useful information for them.
Absolutely.
and they will be away and doing their own thing.
Well, okay, that's really good to know, because if it's like even jumping from the other CAD to BricsCAD. To me, my personal take is less than a half a day, you just discover so much new stuff just moving from that one environment to a BricsCAD environment. It's simple and easy. It's not that difficult at all. It's actually fun. It's like a new little discovery. It's the way I like to look at it.
Yeah, yeah. But of course, programmers of that level tend not to like going to training courses. They like to learn stuff themselves.
True.
And
true.
hopefully, with these videos and maybe some blog posts in future explaining stuff, they'll just be able to pick it up as they go along without having to invest those 4 hours or whatever. But those 4 hours would be a good investment, I think.
Yeah, Steve, can you stop sharing for a second, and then
yeah, sure.
Yeah, we'll go back to full mode. You can see our mugs. There we go. Well, hey, Steve, thank you very much for doing these 3 episodes, for on Blade and everything, to giving everybody a heads up of what it is, and how to actually jump into it and get your hands dirty and start doing things. Number 1, we're going to close up the show here, but so Vince, what do we need to tell everybody?
Like us on Facebook and Twitter and LinkedIn and wherever, YouTube.
Yeah, give us some kudos out there.
And
then also
new things. What do you want to see coming up as a reminder? And
yes,
we're giving away mugs, of course.
Yeah. And then with that, folks, this is the end of season 3. So we've done 24 episodes now, 2 different seasons. In season 2. Season 3, we're going to start probably in the next couple of weeks, and we'll post a notice up on Facebook so you can know when we're actually going to restart the BricsCAD Unplugged again. But once again, Steve, thank you for staying up late, and Vince, thank you for getting up early because you're on California time.
Yeah.
We're totally opposites of the world here right now, but thank you very much, you guys, and I'll make this available up on the YouTube channel here in the next hour or so. And thanks, Steve.
Thanks, Steve.
You're welcome.
Okay.
Thanks. Goodbye.
Bye-bye. Okay, you guys.